We'll eat it tomorrow. Eat it for dinner. I can eat it after the vegetable.
Okay. Let's just throw a couple examples of stuff you should know first, and then we'll go into stuff that I'm guaranteed you don't know. For example, just put up here the square root of 64. I'm hoping that doesn't give you any trouble. That is very good. The square, well, this one, the negative square root of 9 is a negative 3 because you take the square root of 9 and it's negative. The square root of a negative 9 is okay. It is not able to be done. It's actually in math. Abraham will tell you it's an imaginary number, which is helpful. And I can't even write it there. The square root of, the square root of 4/25. Now, a couple different ways to look at this. You could look at this, and you probably know what the answer is, but you could also write this as the square root of 4 over the square root of 25, which ends up being 2 over 5. Or you could look at it as one big group and say, yeah, what fraction times itself gives you 4/25, which is 2/5. Either way you look at that, it's fine. Okay, now we start to get to a little bit more complicated sort of a thing. And the book throws this at you. Everybody got that good? Throws at you this. A to the n power equals b. That always helps me out. A to the n power equals b. Let's actually put something there. Let's put 2 to the 3rd power equals what? Somebody. 8. I just put actually numbers in for the letters just so you can see this. If this is true, then we get this. Where'd it go? Then this is true as well. B to the n equals a. I'll give you a chance to internalize that. Then, and only then, will we actually throw this around. So, adjusting these numbers, the letter B is 8. So I'm going to redo this with my B being 8. The n is 3. And the a is 2, which simply means this. The cube root of 8 actually is 2. Cool. Love that. I don't know if that helps you or not, but the book threw that at you. It looks kind of impressive, that number. I don't know if it really helps you now. Now, understanding that, you can also see that what would be the answer to this? The cube root of a negative 8. Nick says, isn't it impossible? It is possible. Because you are asking what number times itself 3 times will give you a negative 8. And that's possible to get a negative number because 3 negatives times themselves do give you a negative. Okay, so an important thing to keep in mind is as long as your root, odd roots can be negative. As long as it's an odd one. Even ones can never. If I put a 4 here, there's no possible way I can multiply a number times itself 4 times to get a negative number. Because an even number of negatives gives you a positive. So just keep that in mind. Good with that? That's not so bad. Oh boy. Here we go. Another thing the book throws at you. That first one really wasn't that big of a deal. This one, though, is. The nth root of b is the same thing as b to the power of 1 over n. again, I'll give you a second to internalize that, because now we start thinking a little deeper here. Jeremy, does that make sense to you? Okay. Let's put real numbers in here. That means if I have the, let's use square. We never really put the 2 down for square roots, but let's put it here this time. If I have the square root of 16, which you know is 4, it is the same thing as the letter B, 16 to 1 over 2. 16 to the half power, believe it or not, is the same thing as the square root of 16. Okay, which means this. 64 to the 1/3 power. So when you start seeing fractional exponents, okay, when you start seeing fractional exponents, that simply means this. You change this into a root problem. The bottom number goes up here. The outside number here goes here. And if this number were different than a 1, it would go here. But 64 to the first power is 64, so you don't have to worry about it. So 64 to the 1/3 power, children, is the cube root of 64. And the cube root of 64, as everybody knows, is 4. Okay, so this I think is the first time we've ever done fractional exponents. Anything to the half power just means it's square root. For example, 36 to the 1/2 power is the square root of 36, which is 6. Let's say 16 to the 1/4 power is the same thing as the bottom number is the index number there, is the 4th root of 16, which happens to be 2. Oh, let's see if I find it. I was hoping they'd give us something a little stranger, but they don't. Lauren?
What if there's like, if it's like 2/3?
Well, that was what I was going to go. The book doesn't give you that, but I'm going to throw it at you. If you happen to see, I don't know, let's go with one that maybe will work. If you did 8 to the, I don't even know what it is. Let's just say it was 2/3. If we could do this, okay, it would look like this. Your radical sign, the 3 goes out here, the 8 goes in here, and this number on top, the numerator, is actually the exponent of 8. So it would be the same thing as the cube root of 64, which this is not right, the cube root of 64. Okay, is there a cube root of 64? It would be 4. Okay, so if you see this fraction here, you just have to think, okay, bottom number is going to be outside of the radical sign, top number is going to be that thing squared. What if we did, what would be an old one? What if it was 2 to the, give me a number. 5/4? Did you say 5/4?
Yeah.
Sure, why not? Does it work out, Jeremy? So you want the 2, the bottom number is that index number there, 2 to the 5th power. It's the 4th root of 2 to the 5th power, which is 2 to the 5th power. 2 times 2 is 4 times 2 is 8 times 2 is 16. 30 what? 2?
36. Or, yeah, no, 36.
So it'd be the 4th root of 32. Is there one? I don't think so.
Find out.
Well, because the 5th root is 2, so 4th root of 32 is the decimal. I believe it would actually, wouldn't it be 4 times the square root of 2? Is it? No. Simplifying the radical. Would it be? Let's see if this would work. Do you think this would be conventional wisdom here? One spitballing here. But if we break down this and simplify it like we do other square roots, prime factorizing 32, you get what? The square root of 2 times 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 the square root of 2, right? All those multiplied together give you 32. You are looking for what number of times itself? 4 times. So I'm going to guess if you have 4 of the same thing, they will all cross off and give you just a normal 2. and you're left with 2 times the square root of 2? Or is it 2 times the 4th root of the square root of 2? Would that be right?
Why would be four?
Would be 4.
Where's Mr. Johnson?
Where's Mr. Nyer? Anybody out there in TV land, is that what it is? This is way above my level here. What?
1b4. Is that
Is that two?
Did John have your dad watch this tonight?
Wait, what?
It is two times four. It's four because you.
No, but that's only with square roots. This time I have 4 roots, so I have to have the four identical ones to give me a normal number. Frankly, I don't know, so I'll probably edit that out of the picture so I don't look so foolish. It is on YouTube.
That doesn't mean it makes it on YouTube, just so you know.
Wait, these go on YouTube?
Huh?
These go on YouTube?
I'm sure they are.
Yeah, they are.
I'm not
If
saying
you look up,
something,
somehow you look
I
up
said
like
my
Jack or
dad's
something.
birthday was yesterday.
You should make vines out of your
Oh,
Mac.
happy birthday, Mr. Schwartz. What?
You should make vines out of your Mac. 6-second math videos.
Vines of
Oh,
math.
vines.
Here at the
Something
basketball
about that.
game, Shum is keeping score.
I like that one. I was just showing Michelle how the thing works.
Game.
I like the Andy Strauss jacket.
Wow. I'm impressed that you all watched that.
Or the happy birthday one. Everyone's just sitting there.
Been a long time since I've vine. What do we got for an answer for that? Give me that so we can move on.
5.
Yeah, this would be the same thing as the cube root of 125, which means what number times itself? 3 times will give you 125. With that,